All right, let's be honest. Is there something else you're supposed to be doing right now? Do you have a paper due in 10 hours? Is there a stinky pile of laundry slowly inching its way across your bedroom floor? You should be doing those things, but instead, you're here listening to me lecture you on YouTube. Wait. Don't go away just yet. The next 5 minutes will be the most productive bit of procrastination you have done all day.
Hey folks, hope everybody's doing well. Today what we're going to do is we're going to talk about air pressure. That's the next variable on our station model, moving towards eventually predicting weather. Okay, in your reference table, here's the station model. What we're going to focus on today is barometric pressure, which is right here. Now, you guys worked on the conversions before, but I'm going to go through it again. I'm going to talk about air pressure and how it's affected. Now, barometric pressure is air pressure. What people tend to forget is that solids, liquids, and gases are all matter. When you're in a pool, obviously, when you swim to the bottom, you feel the water pressure. What people tend to forget is that when we're just standing here in the atmosphere, air, which is matter, has mass, is being pulled down by gravity, and what it's doing is it's exerting pressure on us. The higher we go up in the atmosphere, the less air we have above us, the less air pressure we experience. It's kind of like swimming to the top of a pool. Now let me show you. When you when you look at a swimming pool, okay, the deeper you go, picture this being down by sea level. The bottom of the pool would be, for instance, Northport, because we're very close to sea level. As you go up into the mountains, you're going closer to the interface between the atmosphere and space. There's less air molecules, so you're going to have less pressure pushing down. Think about it when you go to the beach, when you're laying there and you bury yourself in sand. The deeper you are and the more mass you have above you, the more pressure you experience. So pressure increases with depth. Another illustration that I found was this one right here. When you're standing in the pool, the most pressure is on your feet and the least pressure is on your chest up here, because even though the water isn't sitting directly on you, some of the force is being dispersed to the rest of the water into the pool. As you go down, pressure increases on your body. There are fish that live at very deep depths, and their body, like tilefish, their bodies exert pressure outward, and the water actually holds them together. If you go deep sea fishing, as you reel up the fish, as the fish comes to the surface, it actually expands. Okay, so the deeper down you are in the atmosphere, remember this is, just an analogy. When you're in a swimming pool, as you move to the top, this is like moving towards the top of the atmosphere, the thermosphere. The troposphere would be down here. This is where the most pressure is. Okay. So now that you have a mental image of how air pressure works, as you decrease in elevation, air pressure increases. As you move to the higher elevations, it decreases. Okay, so increases as you go down, decreases as you go up. Air pressure is the force of air pushing down on a unit area of a surface. The instrument that we use is called a barometer, and what we do is we use sea level as our starting point, as our reference. In your reference table, we have this conversion chart. Air pressure is measured in millibars and inches right here. Sometimes they have you do conversions back and forth. We don't do it mathematically. You just locate the number and read straight across. Okay, 1 atmosphere is labeled right here because that's sea level. If you're standing at sea level, you have 1 atmosphere. As you move up in elevation, air pressure will decrease. As you move down in elevation, air pressure will increase. Okay. The two things that affect air pressure are temperature and humidity. We've said over and over again that as you heat something up, the molecules speed up, they spread out. If they spread out, there's less mass in that parcel of air, that volume, so it's going to weigh less. So warm air weighs less than cold air. If you ever noticed, if you go down to the beach, the waves, it's a lot rougher, the water, in the winter. That's because what's creating waves is the friction between the air and the surface of the water. Cold air is more dense, and when the wind blows, it can exert more force on the surface, and it kicks up the waves. So beaches tend to erode away in the winter, and they tend to deposit because they're slowing down. The kinetic energy drops the particles in the summer. So sometimes if you live on the coast, beaches will recede in the winter and then they'll redeposit in the summer. So temperature, warm air is low in density, light in weight. Cold air is dense and heavy. Humidity. This one is contradictory to the way that you would think. Normally when something gets wet, you think it's heavier, but when it comes to gases in the air, H2O as a gas actually weighs less than the other molecules that are floating around, like O2, N2, CO2. Picture these as bowling balls, and picture water molecules in the gas phase as balloons. The more water, the more balloons you put into the air, the more O2, N2, CO2 that gets pushed out of the way. And for that volume of air, the mass and the pressure is actually going to go down. So when there's a lot of water in the air, for instance in the summer, when there's a lot of evaporation, the air is warm, so the molecules are spread out, and warm air holds a lot of water, so it's going to be lighter in weight. So warm, moist air weighs less than cold, molecules together, constricted, dry air. So in the winter, the air is heavier, and in the summer, the air is lighter. Okay? These are just some illustrations. When you're at the top of a mountain, air pressure is going to be less. The lowest elevation in North America is in Death Valley. It's called Badwater Basin. The reason why it's called Badwater is because minerals get washed downhill to low points of elevation, and then when the water evaporates off, it deposits those. So in Badwater, we have salt flats. So obviously you can't drink it. Okay, and this is another picture of Death Valley right here. Now what I'll do is I'll show you two of the instruments that are used for measuring air pressure. Air pressure, this is called apparently a Torricellian barometer, and this is a dish full of mercury, and what they do is they invert a glass tube, and it's full of mercury, and as air pressure outside increases and it pushes on this exposed surface, what it does is it forces the mercury up through here. Okay, there's a vacuum that's going to resist the mercury moving upward, so it compresses it and it pushes it up. And then what they do is they graduate the cylinder. They put numbers on it to indicate the different air pressures. Okay, so air pushes down on this, forces it up the tube, and the higher it goes, the greater the air pressure reading. As air pressure is released, like let's say it gets warmer out and air pressure decreases, then it'll drop down. Okay, another type of barometer is called an aneroid barometer. And what this has is, this has a sealed container that has a certain air pressure inside of it. And what happens is as air pressure outside increases, it's going to push in and compress this, and what it'll do is it'll mechanically move this needle. So as air pressure outside increases, like let's say you decreased in elevation, you went down to Death Valley, you would be at the bottom of the atmosphere. There'd be more air pressure. It would compress on this, and then this mechanical needle would move up. Okay, if you climb to the top of a mountain, or if you were in an airplane, what would happen is air pressure would decrease. This would allow this to expand, and then this little mechanism right here would move down, and you would read the needle. When you're in an airplane, inside your head, you have a certain amount of air pressure. If the plane takes off, as the plane is going up, air pressure outside is decreasing, so your eardrums, okay, are going to bend outward. That's why your ears hurt. As an airplane descends, or if you're in a car driving in the mountains and you start to descend, what happens is you have low air pressure in your head, and before it reaches equilibrium with the surrounding atmosphere, your eardrums start to push in. So the air pressure inside your head sometimes changes slower than what's around in your environment, and you feel that pressure on your eardrums. Okay, the last thing I wanted to show you was, I'll just review, we had mentioned it when we were talking about station models, but how to convert air pressure on and off a station model. First of all, it's in millibars, okay, and to save space, what we do is we put this in code. If this number is below 500, what you do is you add a 10. If it's above 500, you put a 9 in front of it, and in both cases you move the decimal. Now, if you can remember that you put a 9 or a 10, you can always refer back to this example in the reference table and say, okay, well, this one's below. I can't remember if you add the 9 or the 10. Below their example, they put the 10. So above has to be the opposite. So that's what I tell people, to use this example. All you have to do is remember 9 or 10 above and below 500. You don't need to remember which, because you can always refer back to this. The examples, if, for instance, you have an air pressure of 1002.3 and you want to put it onto the station model, drop the 10, remove the decimal, and it becomes 023. If you have 995.4, you drop the 9, drop the decimal, and it becomes 954. Okay. Once again, if this is a station model, and the number always goes right here. If you want to read this off and give it meaning, okay, what you have to do is say, is that above or below 500? It's above. So when it's above, you put a 9. So then 954, you add the 9, add the decimal, and this is in millibars. Okay, if you simply write 954, it's incorrect. What you have to do is it's got to be converted. On the station model, it's understood that these are in code. Once you read it off, it absolutely has to have units, and it has to be converted. Okay? So what I'm going to do is I'm going to give you guys some more practice with station models. I want you to do the conversions. I want you to use your reference table to figure out where the placement is and how it should be properly written. And we'll continue from there. Once we get through all the different weather variables, then we'll start tying them together, see how they interact, and do some weather predicting. All right? Hope you're enjoying your time at home, and have a great day.